Unit 2, Objective 2, Solving Radical Equations. For Level 1, we have 9 review questions and then an SAT practice question. So I'm going to have you try the review on your own. So I would pause the video and try to factor and multiply, and then start the video again, and you can see how you did on them. So number 1, first of all, we're going to change that to x squared minus 2x minus 8, because that was a typo, and if you don't have that, it won't factor. So that's going to be x minus 4, x plus 2. And that is because you need two numbers that multiply to be negative 8 and add to be negative 2. Number 2, x minus 7, x plus 3. Two numbers that multiply to be negative 21 here and here, and add to be a negative 4. So they multiply to the third number and add to the second number. Number 3, x minus 8, x plus 2. So again, you're looking for two numbers that multiply to be the third number. So they multiply to be negative 16 and add to be negative 6. All right, so that's the factoring. Multiplying. For the multiplying, in the first one, we're just going to distribute, normal distributing, except we do have to review our rules of exponents. So negative 6, and that would give us a to the third minus 4a squared b. For number 5 and number 6, you're squaring a binomial, and when you square a binomial, you multiply it by itself, or you write it twice. So that 2 means that you write it twice, and then you do FOIL or binomial distribution, double distributing. So however your Algebra 1 teacher taught you. So that's going to give you x squared minus 5x minus 5x plus 25, or x squared minus 10x plus 25. This one, 3x plus 1 times 3x plus 1 is going to give me 9x squared plus 3x plus 3x plus 1, 9x squared plus 6x plus 1. For the last part of the review, we've got some rules of exponents, we've got some rational exponents, some roots that are not just square roots. So again, I'm going to pause and have you try it. So in the first one, we would take the 2 and the 10 and divide 1 and 5, and then we would use the rules of exponents. So negative 3 minus 6 is a negative 9. To make the exponent positive, you would put it in the denominator. So 1 over 5x to the 9th. Number 8 is going to be the cube root of 8x to the 6th, y to the 3rd, because we remember to the 1/3 power is an index of 3. And then we simplify. Cube root of 8 is 2. Cube root of x to the 6th, x squared. Cube root of y cubed, y. Number 9, we're going to do each individual index. So the 5th root of 32, you have to find out what number multiplied by itself 5 times is 32. So it's going to give us a 2. The 5th root of x to the 20 is x to the 4th. The 4th root of 16, what number multiplied by itself 4 times is 16. That is also 2. And the 4th root of x to the 12th is x to the 3rd. And so now we simply divide, use our rules of exponents, and the answer is x. Number 10 is a SAT type problem that relates to literal equations, which was Unit 2, Objective 1. We are given this equation here, and there's a lot of reading here. And one of the strategies for SAT problems is to figure out what the question is. So kind of scan and look for what or which or where. So which of the following is the correct expression for the depth? So if you look at all of them, they're h equals, h equals, h equals, h equals. So that must mean that I have to take that equation and solve it for h. So isolate the h. So I'm going to do p subtract p sub 0 equals little p, little g, little h. Now to get h by itself, all I have to do is divide away the little pg. And so I just come over here and I find the one that matches that. So p minus p sub 0 over pg, and that's a. All right, now we're going to talk about this objective, which is solving radical equations. So when you solve radical equations, we essentially square both sides of the equation to undo the radical. So in this first problem, we would square both sides. On the left side, we would get x, and on the right side, we would get 9. One of the most important things about radical equations is that you always need to check your solution. So make sure that you substitute that value back into the original equation. So square root of 9 equals 3, 3 equals 3, checks. Example 2, we will begin again by squaring both sides. Square root of x squared is x, and negative 3 squared is a positive 9. When we plug that back in to check to see if it's a solution, the square root of 9 equals negative 3, 3 equals negative 3 is an untrue statement. And so we put a slash through the equal sign. Notice here that we solve correctly, but when we plug the solution back in, the equation is not balanced or not true. This is going to happen with radical equations. We will get something called an extraneous solution. In this context, it means its solution is mathematically correct. But as far as plugging it back into the original equation, it doesn't make it true. So you've done the math correctly, you've ended up with this equation, but then when you go to plug it back in, it makes the equation untrue. So we label that solution as an extraneous solution. So below in the box are the 4 steps for solving radical equations. And you're going to want to do this every time you are solving a radical equation. So you're going to want to isolate the radical. Now the first 2 examples, the radical was already isolated. And then you're going to want to apply the power rule. If it's a square root, you're going to want to square both sides. If it's a cube root, you're going to want to cube both sides, and so on. Then you're going to want to solve the equation that you get after you use the power rule to both sides. Then you want to go back and check your solutions to see if you have any extraneous. All right, so for example 3, first thing you're going to want to do is isolate the radical. So divide by 3, divide by 3. So we're going to get the square root of x plus 4 equals 5. So now we've isolated the radical. You can see the radical is all by itself. So now I'm going to square both sides to undo the square root on the left side. We end up with x plus 4. On the right side, we end up with 25. Solving, subtract 4, x equals 21. Now all you have to do is test your solution. So I'm going to substitute that 21 back in. So it's going to be 3 times the square root of 21 plus 4 equals 15. 3 times the square root of 25 equals 15. 15 is going to equal 15. So it checks. Example 4. You're going to do the same thing you did in example 3. You're going to get it all by itself. So we're going to get 3 root 2x minus 1 equals 6. We're going to divide by 3. And we're going to get root 2x minus 1 equals 2. So sometimes it takes a couple steps to isolate the radical, and then you will square both sides in this case, or raise both sides to whatever power the index is. 2x minus 1 equals 4. 2x equals 5. x equals 5 over 2, or 2.5. When you substitute that back into the original problem, you're going to have 2 times 2.5, which is 5 minus 1 is 4. Root 4 is 2. 2 times 3 is 6. 6 minus 9 is negative 3. And so that solution checks. Example 5. We're going to isolate the radical. So we're going to get the square root of x plus 1 equals negative 6. You're going to square both sides, and you're going to get x plus 1 equals 36. You're going to subtract 1 from both sides, and you're going to get x equals 35. When you take 35 and plug it back in, you get 35 plus 1 is 36. Root 36 is 6. 6 plus 2 is 4. 4 does not equal negative 4. Therefore, 35 is not a solution. And so we X it out and we write the word extraneous. You have to write the whole word out. So 35 is an extraneous solution. So there's actually no solution to that problem because 35 is extraneous. Number 6. Again, we're going to isolate the radicals. They're already isolated, and so we're going to begin by squaring both sides. On the left, we get x minus 4. On the right, we get 2x minus 13. And when you solve for x now, you're going to get x equals 9. So subtract the x over to the other side, add the 13 to the other side. Now you're going to substitute the 9 back in. 9 minus 4 is 5, so square root of 5 on the left. 9 times 2 is 18, minus 13 is the square root of 5. Checks. And we don't even need to, do the square root of 5. We just know that they're equal. Okay, last one. Again, isolate the radical, which it already is. Square both sides. On the left side, when you square x, you get x squared. On the right side, when you square the square root, they undo each other. And so you get what's on the inside. X squared minus 5x plus 15. Minus x squared minus x squared, 0 equals negative 5x plus 15. Negative 15 equals negative 5x. X equals 3. And once again, you're going to take x equals 3 and you're going to substitute it back in to make sure that it makes the original equation true. So if I plug it in, it's going to be 3 squared is 9, subtract 15 is a negative 6, plus 15 is 9. Square root of 9 is 3, equals 3, and that checks. All right, what about if we are asked to solve a word problem, and that word problem has a radical in it? So this application is one where we're given a formula for dropping a ball, and the h variable represents the height the ball is above the water, and the t represents the time it takes for the ball to drop into the water. So the formula is given to us, and we're going to use that formula to answer the questions. How long is the ball in the air, and when the ball is at 16 feet? So how long is a question of time. So t equals 1 over 4 times the square root of 25, subtract, and now in place of h, we're going to put 16, because it says the ball's at 16 feet. And so now you're just going to simplify. 25 minus 16 is 9, root 9 is 3, 3 times 1/4 is 0.75. So very quickly the ball is into the water. 3/4 of a second, or 0.75 seconds. B, how many feet above the water will the ball be after 1 second? So now I'm being given a different time or a different variable. I'm being given time. So 1 equals 1/4 times the square root of 25 minus h. So we see that h is inside the square root, so we're going to follow the steps that we just did in the previous examples. we're going to begin by isolating the radical. So I'm going to multiply both sides by 4 over 1. On the left, that's going to give me 4, and on the right, it's going to give me the square root of 25 minus h. Why did I choose 4 over 1? Because 4 over 1 times 1 over 4 divides away the 4's, and we're left with the radical isolated. Now we're going to square both sides. On the left, we're going to get 16, and on the right, we're going to get 25 minus h. We're going to subtract 25 from both sides, and we're going to get negative 9 equals negative h. We're going to divide both sides by negative 1, and h is 9 feet. All right, radical equations that are not square roots. So all the ones we've done so far have been square roots. What about ones that aren't square roots? What do? We follow the same steps up until the part where you square both sides. So again, we begin by isolating the radical. So that will be the 4th root of 2x plus 3 equals 1. Now, instead of squaring both sides, the index is a 4. And so what we do is we raise both sides to that index. Because if you take the 4th root of an expression and raise it to the 4th power, the 4th root and the 4th power will undo, and you will have left 2x plus 3. On the right, 1 to the 4th is, of course, 1, because 1 multiplied by itself however many times is always 1. 2x equals negative 2, subtract the 3 over x equals negative 1. And you have to do the same things that you did before in terms of testing your answer to see if it works or if it's extraneous. So if you plug negative 1 in, you're going to get 2 times negative 1. Negative 2 plus 3 is 1. The 4th root of 1 is 1. Plus 6 is 7. And so it checks. In example 10, we have cube roots. They are both isolated. There's nothing in front of them. There's nothing around them. And so again, we're going to raise both sides to whatever the index is. So the index here is 3. And so we would say we're cubing both sides to undo the cube root. 2x plus 7 equals 3x minus 2. Subtract the 2x, you get x. Add the 2 to the other side, you get 9. And again, you want to test to make sure that 9 is truly a solution. So 9 times 2 is 18, plus 7 is 25. So the cube root of 25 equals 9 times 3 is 27, minus 2 is 25. And again, we don't have to turn that into a decimal. We're all good. It checks. Moving on to the focus, level 3 focus. These are going to take a little bit longer, but again, we're going to do the same steps. So we isolate the radical. The radical is isolated. It's a square root, so we're going to square both sides. On the left, we're going to get 4x plus 12 because the square undoes the square root. But on the right, we're going to get x squared. Now, in order to solve, we have an x squared term, which means we're going to have to use factoring to solve. And so the next step is to always move all terms to the side where the x squared is, and always try to keep x squared positive. So that's going to become 0 equals x squared, and I'm subtracting the 4x to the other side, and I'm subtracting the 12 to the other side. And now we reviewed this. How do you factor? Well, you write two binomials. You write x in the first position for both binomials because x times x will give you x squared. And then in the second two positions, our pattern is we are looking for a product that is equal to negative 12 and a sum that is equal to negative 4. And so that is going to be minus 6 and plus 2. Now, according to the zero product property, we're going to set each of those equal to 0. We're going to solve. So we're going to get x equals 6 and x equals -2. So now we have the potential for 2 solutions. But again, we have to check. So we'll start with 6. 6 times 4 is 24, plus 12 is 36. The square root of 36 is 6, equals 6 on the other side. So again, you are substituting the 6 into both places where you see x, and that one checks. When you substitute in -2, -2 times 4 is -8, plus 12 is 4, square root of 4 is 2. But 2 does not equal the -2 that you would put on the other side. And so we X it out because it is extraneous. So please pay attention to the end of this problem and how you present your answers. All right, example 12. Again, we're going to isolate the radical, which means I have to add 5 to the other side. So this is going to give us the square root of x plus 7, but on the right side, it's going to be x plus 5. Follow the same steps. Square both sides. On the left side, again, we're left with x plus 7. But on the right side, when we square x plus 5, that means we write it twice. X plus 7, and then now we do the FOIL or the double distribute. X squared plus 5x plus 5x plus 25. So x plus 7 equals x squared plus 10x plus 25. Now what? Well, we're going to do what we did in the last problem. We're going to move all terms to the side where x squared is, and we always want to keep x squared positive for when we factor. So that's going to be 0 equals x squared plus 9x plus 18. Factor. So we're looking for two numbers whose product that multiply to 18 and then add to 9. So it's going to be x plus 6, x plus 3. Now you're going to do zero product property. X plus 6 equals 0, x plus 3 equals 0, x equals -6, or x equals -3. And the final step is to test to see, do we have two solutions? Do we have one solution? Or maybe we have no solutions because they're both extraneous. So we'll start by plugging in -6. -6, so watch how I substituted it. The square root of -6 plus 7 minus 5 equals -6. So notice that the -6 is getting plugged in wherever there is an x, right? So that's going to be the square root of 1 is 1. 1 minus 5 equals -6. That's not true. So this guy is extraneous. So we're going to X it off and write extraneous. Let's try -3. So we're going to substitute in -3. So -3 plus 7 is 4. Square root of 4 is 2, right? So that would be the square root. So I'm up at the top now. -3 plus 7 minus 5 equals -3. Does it work? So that's going to be square root of 4 is 2. 2 minus 5 is -3. So it works. So please put a big box or circle whatever is a solution, X out what isn't, and write the word extraneous. So again, in order to get the answer completely right, the end of the problem must look like mine. All right, example 13. Let's try this one. So again, we're going to square both sides. On the left side, we're squaring the square root, so we're just going to get x minus 1. On the right side, we're going to write x minus 7 twice. That's going to be x minus 1, and then it's going to be x squared minus 7x plus 49 x squared minus 14x plus 49. Zero out the left side. And factor to solve. So I added the 1 to the other side, that made the 4950. I subtracted the x to the other side, that made the negative 14, negative 15. We're looking for two numbers that multiply to be 50 and add to be negative 15. So I made a teeny mistake there because I need those both to be minus. So x minus 10, x minus 5. Because I got to get a positive 50 but a negative 15. So x minus 10 equals 0, x equals 10. X minus 5 equals 0, x equals 5. Test them, see if they both work. So I'll start by plugging in 10. So that's going to be the square root of 10 minus 1 equals 10 minus 7. So that on the left side, that's going to be 3, and on the right side, it's going to be 3. So we know that works. Plug in 5. 5 minus 1 is 4. The square root of 4 is 2. And 2 does not equal negative 2. So this guy is extraneous. You don't have to memorize the word extraneous. It will be written somewhere on your quiz that you can reference so you don't have to worry about spelling it. All right, last one. Let's see what we get. Square both sides. We're going to get x plus 6 equals x plus 4 multiplied by x plus 4. So remember, if it has a square root, when you square it, it's just what is on the inside. When it doesn't have a square root, you're squaring the binomial, and so you write it twice. X plus 6 equals x squared plus 4x plus 4x plus 16. X plus 6 equals x squared plus 8x plus 16. Zero out one of the sides. X squared, subtract the x plus 7x, subtract the 6 plus 10. Factor. Two numbers that multiply to be 10 and add to be 7. Plus 5 and plus 2. Zero product property. X plus 5 equals 0. X equals negative 5. X plus 2 equals 0. X equals negative 2. Do they work? Well, let's start with x equals negative 5. So that would be the square root of negative 5 plus 6 equals negative 5 plus 4. That's going to be the square root of 1 is 1 equals negative 1. No. So extraneous for that first one. All right, negative 2. Plug it in. Negative 2 plus 6 is 4. Square root of 4 is 2. Negative 2 plus 4 is 2. Yep, it checks. It is a solution. Okay, the challenge problems, we're going to skip those.